Hey everyone, Chang here and welcome to my channel. Today we're going to focus on a specific tool that means only really one thing. I'm talking about these guys right here. This is factorial. Now, the common joke is that next to each of these numbers are an exclamation mark. So rather than, for example, 5, like a normal person, right, they would shout 5 at you, or 7, then they shout 7 at you, right? And so on and so forth. Now that's a joke. The exclamation mark actually means something drastically different. Now factorial is actually a fairly simple concept with very limited things they can really ask you about. It's only really useful, to my understanding, and you guys can correct me if I'm wrong, in finding combinations. That's where I've mainly seen it used, and that's usually more of a statistics counting kind of front instead of just regular math, right? The only time that you'll see this is basically these kind of problems. They'll ask you for basically definitions of what factorial is and problem that involves just understanding it and then eventually simplifying it. So let's just look at this one, for example. 5 factorial. It usually has a number and then an exclamation mark behind it. What it's saying is basically the number, whatever the number is, and then you sort of incrementally go down by 1 all the way until you hit 1, and you're multiplying all those numbers. So 5 factorial would just be 5 times 4 times 3 times 2 times 1. Now, a common misconception is that they go all the way to 0, which makes no sense, because if you multiply by 0, guess what? It's going to be 0, and factorial would be basically useless if it always ends at 0. So it always ends at 1. So in this case, this is 5 factorial. So 7 factorial, you can sort of guess what it is, right? In this case, it would just be 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on and so forth, right? 4 factorial would just be 4 times 3 times 2 times 1. And we can go on and on. Now, the one thing I really like about factorial is if you really enjoy, I guess you could say, math concepts, and you hate the fact that calculator basically ruined the fun of everything because they do all the calculation, these are the bane of, I guess you could say, calculator's existence. Now, what do I mean by that? Well, here's the thing. Let's look at this, for example, 4 factorial, right? That's just 4 times 3 times 2 times 1. 4 times 3 times 2, and then 1 is just basically 24, right? If it's 5 factorial, that's technically just an increase in one number of factorial, right? It doesn't seem all that bad. But that means this right here, which is 24 already, times 5. As you can see, the number gets drastically bigger very, very quickly. So just something like, most likely, I'm going to assume, like 50 factorial, it's pretty close and overwhelming a calculator. And then of course the main one that I've seen is that they usually poke fun by saying, why don't you just try 100 factorial? And in a lot of graphing calculators or scientific calculator, they would give you error and just basically say that you overwhelmed the calculator. So that's the fun thing about factorial. It basically, you could say, it's like a calculator destroyer, right? Now, that's the key though. Because factorial is just a string of multiplication that the numbers get drastically large, there's really only a limit of things that you can really do. And the main one is simplification. They would give you a problem hoping that you would understand the definition of factorial and then use it to simplify. That's all it really does. Now, for those of you guys who really want to know, just because, you know, I'm always poking fun of sometimes you have to memorize formula, here's the formula for factorial. If you have n factorial, n as some variable, some number, right? Notice that they always have to be whole numbers. That's basically going to be n times n minus 1 times n minus 2, and then all the way until 1, which you can sort of guess. That's just a definition of factorial as well. So if you guys wanted the formula, there it is. Now let's just look at some of these problems very quickly, ignoring all the other scribbles, right? 25 factorial and 24 factorial. 25 factorial is basically 25 times 24 times all the way to 1. Now, this is an example of a problem that you would normally see. Well, in the bottom, 24 factorial, right? It's just 24 times 23 times 22 times all the way to 1. Now, all it is that, well, you remember 25 starts at 25, then 24, but then it just goes 23, 22, 21, all the way down to 1. The bottom is 24. So basically, something like this, you can simplify it, right? The 24s will go away, right? Because they're all multiplication, so you can just simplify it. And of course, there's the 23 and 22 and 21 all the way until, well, 1 and 1. You can sort of cancel that if you wanted to. And basically, everything cancels, right? So what you have left over is just 25. So that's a common type of problem that you would see in factorial. This one would be 25. This one is a fun one. This is sort of sneaky, but it's not that bad, right? 5 factorial, we know, is 5 times 4 times 3 times 2 times 1, and the bottom is 20. And then if we can see it right away, 5 times 4, right? 20 is just 5 times 4, and then realize that all of a sudden these cancel, and we have 3 times 2 times 1, and of course that's 6. If you wanted to be a smart aleck with your instructor, which I think is actually kind of fun, do it, right? 3 times 2 times 1 is just basically 3 factorial, and you can give them that as an answer, right? Now this one is another one it pokes fun at the definition, right? 15 times 14 factorial basically is 15 times 14 all the way into 1, and the bottom one is 15 factorial, so it's 15 times 14 times all the way to 1. And then of course, if that's the case, then everything cancels, right? Because the 15 goes with 15, 14, 14, all the way into 1, 1. And so that just becomes one big one. All right, cool. So these are numbers. Now, of course, we always try to push the boundary a little bit, right? These are going to be fairly easy problems that you could sort of simplify. But there will be occasions where you will see problems where they start using variables just to see if you truly understand the definition of factorials and how to simplify it. So let's look at those problems really quickly. Now, this is a side note that 0 factorial. Now, I was looking around and trying to figure out an explanation for it, because when I learned factorial, I was basically told to almost like memorize this, that 0 factorial technically just equals 1. And I was trying to figure out why is it 1? Is it just defined as 1? Because there are some things in math that it sort of irks me in a way, because they just define it as that. Like, there's no like logical agreed upon explanation on why that's the case. It's just, let's just make sure we define it this way so everything works. Because if we don't, then it doesn't work, right? I don't like that, but I mean, this might happen to be the case. I might not just know why. The most convincing one I've seen is that the explanation is, with factorial, as I mentioned in the beginning of the video, is mainly used to find combination of things. Combination as in different ways, to organize. And that's what factorial is used for. So by that definition, usually factorial, for example, when you say 5 factorial, it's basically saying that you have 5 objects, you're trying to find all the different orders that you can arrange the 5 objects. And I'm going to go into more details of this in a future video. But basically, it's talking about combination, right? 5 objects, arrange it however you want. Well, 0 object, how can you arrange it? And the argument is that it equals 1 because when you have no object at all, there's really only one way to arrange 0 object, which is, ta-da, 0 object, right? So that was the only, I guess, the more convincing explanation. Some of the other ones, I kind of think is a stretch, but just to let you guys know, in the future, and I'm sure some of you guys will encounter this, and some of the instructors or people who create tests and stuff will give you this. 0 factorial is just 1, plain and simple. Now let's get back to the problems, right? This is, as I mentioned, usually ones where they use variables. Now, there's always going to be variations of this, but the way of approaching the problem and the way of understanding and solving the problem is basically the same thing as when we were working with numbers. So let's look at this, for example. The first one right here, n plus 1 factorial over n factorial. Well, we know by definition of factorial that basically it's just going to be n plus 1, and it's going to be multiplying the next one down, which is just going to be n, right? You can think of it as n plus 1 subtract 1, and it's going to be n minus 1, and so on and so forth, all the way until you multiply by 1. Plain and simple. The bottom is going to be the same thing. Now, n factorial means you start at n, and then you start going down by 1, right? N minus 1, and then n minus 2, and then all the way down to 1. And so, if we wanted to simplify this, once again, n plus 1, there's nothing you can cancel down here. But the parentheses let us know that these individual things are all multiplication, so technically we can still cancel. N goes away. N minus 1 goes away. And of course, by that same logic, everything else goes all away until you reach 1, 1, which can go away as well, technically. Right? So in that case, what's left over? Just n plus 1. So notice that it's really just not any different from when you're just simplifying numbers. It's just that when you use variables, it looks a little crazy scary. Now, this one's another one, right? This one is slightly different from this one, whereas the top one has more variables, or more terms, I guess you could say. And hence, we have something like this. Well, this one is a little different. The bottom is n minus 2 factorial, so we start off with n minus 2, and then we multiply by n minus 3, and it goes on all the way into 1, right? The bottom one, right here, is going to be n plus 1 factorial. So it's just going to be n plus 1 times n times n minus 1 times n minus 2 all the way until 1. And the reason I wrote it all out is just because we can see it, right? Well, n minus 2 and n minus 2, that goes away. And then n minus 3 goes away. And then all those goes away until we have whatever's left over. Well, the top, everything goes away. So it's just 1. That's just a common mistake that we might encounter. If everything goes away, just make sure that wherever it is, it's just 1. Technically, this is just over 1, right? Okay, cool. So that's 1. And then what we have left over, we have n plus 1 times n minus 1. And that's just plain and simple. So once again, these are factorials with variables, but notice that the way of understanding, the way of solving it is the same thing. All they can really do is ask you to basically see the pattern, and the most they can say is simplify it. So let's look at the number version. That is slightly more complicated, but I think you guys can do it. Let's see. Now, this one here is a number factorial, once again, but it's slightly different because now you notice that there are multiple factorials in this problem. Not just top and bottom, but then look, at the bottom we have 2 of them. Now, is it any more difficult? Yeah, probably, but really not all that bad, right? By definition of factorial, we can still figure out what this problem is talking about and then just start simplifying it. Well, the top one, we have 10 times 9 times 8 times 7, and I'm not going to be lazy, I'll just write it all out. 6, 5, 4, 3, 2, 1. That's 10 factorial. All right. Now, the bottom is a little different, right? 5 factorial is just going to be 5 times 4 times 3 times 2 times 1. 3 factorial. They're right next to each other. Technically, they're just multiplying. So in this case, it's just going to be times 3 times 2 times 1. Right, and I'm just going to do the parentheses so you guys can see the 2 different factorials broken down. There it is. Okay, and then, so what do we have? Well, we can be creative a little bit, I guess you could say. Right, these guys are all going to be gone. 5, 4, 3, 2, 1. Right? Why? Because we have here 5, 4, 3, 2, 1. Right? They're all multiplication gone. Well, 3 times 2 times 1, technically, if we figured this out, 3 times 2 times 1 is just 6. So we can just cancel this guy and this whole thing right here. And so what do we have left over? Right? We have basically 10 times 9 times 8 times 7. Now, is there a shorthand notation for this? No, not really, right? There is, I mean, technically you write this as a shorthand notation, but basically now you have just 10 times 9 times 8 times 7. And that would be your simplified answer. And of course you could multiply it all out, but I'm kind of lazy and I don't want to do that. So after you multiply all this out, that's your simplified expression of this right here. So plain and simple, factorial. So hopefully by the end of this video, you realize that factorial is actually an extremely simple concept, right? Basically, all it is just multiplication, right? From that number all the way down to 1, plain and simple. Now, what I love about it, once again, is just the fact that it's a calculator killer because it's a number that grows so fast, so quickly. But because of that, it's very limited on what they can do to you, right? They can always ask you stuff about the definition, which we've done, right? They can always ask you basically how to simplify understanding the definition from top to bottom, and you're basically, canceling things out. There might be a little room to finagle maybe some addition or subtraction problem, but there's really not much you can do with factorials other than that. So the next time they give you a factorial problem, of course you can solve it very easily, and of course if the answer is nice and simple, throw a factorial back at them, and you can always have that option of shouting at them, whoever gave you that problem, whether it's the instructor or the test, I guess you could say proctor. But of course, keep in mind that there are consequences for action. So when you shout at them, please have a proper explanation, understanding that it is using an exclamation mark, and hence, you are justified in your shouting. Thank you for watching this video. See you in the next one.